Okay. I think it's the top of the hour now, so um, hopefully everyone's okay for me to start now. Unfortunately, I can't see the Matrix chat, but hopefully people can write their questions in the shared notes section. And yeah, let's just get started then. So I'm Philip Heron. I'm the guy working on the GCC front end for Rust. So it's I'll get into showing what that is and what it's all about. There's a lot of slides in here to go through. I just want to point out the little Ferris crab at the top hand the right hand side, where it's holding on to the GNU logo here. I spent probably far too much time trying to crop off the claw and get it layered up correctly. Philip Krona has given me the idea from that to do that one. But I think it's kind of funny. It's just the idea that Rust is then grabbing onto GCC here, and obviously, well, thanks for open source security and Embecosm as well. So let's see. Next slide. So in this presentation, sort of want to go through a few things. Want to sort of talk about like the motivations of it, like the what, why, and how. Why are we working this? Why, what even is it? What sort of caveats are there? All that sort of stuff. What sort of progress has already made? I want to sort of give maybe a little bit of a demo on how it actually works, what to expect when you actually run this thing. What's the sort of status of it at a high level? I want to talk a little bit about the community I've been trying to develop. Talk about future work, and then question and answer sort of section towards the end. And so feel free to stop me, even though I can't see the chat. Hopefully, you can click the raise hand or do the webcam thing or put it in share notes. I'll try and keep an eye on these things as we go on. So what is a front end? I stole this like an old diagram I made years ago. It's maybe not the best diagram, but it's just to give you a high level idea of what I'm actually working on here. So this is sort of a really high level architecture of a traditional compiler, which just so happens to relate quite okay to GCC. So you got source code coming in here, and then you got this notion of a front end, and then it's passing something over to a middle end to do optimizations to then pass those over to the back end to actually then generate assembly. So the piece I'm working on in here is just the front end itself. And then we're actually producing the generic code over to the middle end, which then turns into the the RTL and all that sort of magic in the back end, which then gives you your assembly. You run your assembler on it, you get your object code, and you run your linker. So it's just traditional compile pipeline that you would expect. So this is the piece I'm going to be talking about, is just this front end piece here. And the reason I just want to show this diagram is that it's alongside other front ends in a larger system, which you'll also be familiar with. So what is this? So we want to make a full implementation of Rust on top of the GNU toolchain. That's sort of a high level way to think about it. We want to make this as robust as what you would expect from a normal C and C++ front end from GCC. We want it to be of the same level, quality. We want it to be upstreamed, obviously. So when you get a build, or if you get a tarball of GCC, you will also get a Rust front end as well. Obviously, in that we are also reusing all of the GNU toolchain here. So that means we're getting to reuse binutils, LD, assembler, GDB. We're also writing this in C++, so that's something maybe to talk about later on. And so that means it's much more easily bootstrappable going forward, because obviously GCC is written in C and C++, C++ now, and we want to reuse things like the official Rust, libcore, libstandard, and so on. We want to try and reuse those and as absolute minimal sort of changes to those as possible. So that's sort of the idea of what this will eventually be. And you'll see a demo later on to actually show you what it's like to invoke it and so on. So personal motivations, I think, is an important thing to talk about. So, I was working on this, quite a long time ago. And so I really do enjoy working on big projects. There's something really satisfying about sinking your teeth into something. It's got a lot of scope there. I think, as I mentioned, And before the talk started, I'm a really big fan of people like Andreas Kling and Tim Morgan. I know those guys on YouTube who like, broadcasting and showing their hacking sessions on their projects. I always enjoyed watching those. And even when their projects are really big, it doesn't matter. You learn so much by watching these guys, and you sort of, it's the community aspect of that I really like. And then a side note to that, GC was always going to provide a contrast to LLVM, in terms of, code size, something people talk about, like, whenever there's the website phronix.com, you always see them posting GC versus LLVM. So that'll be pretty interesting down the line, especially to see how these things compare in terms of code generation. It'll be interesting to see how well GC actually handles a modern, high-level language like this. Although Go does rely on a lot of runtime features, and so it'll be interesting to see how GC will be able to optimize this sort of something that's a bit more similar to C++ in terms of what you can do. Be interested to see the register allocations, for all the different targets it supports and so on, energy efficiency. There's all sorts of different features to compare and characterize at some point. I think there's already some questions coming in here. What mechanism are you using to pull in the Rust libraries as Git submodules? So at the moment, we're not pulling in any of Rust sort of code at the moment, because we're not there yet to start compiling libcore, libstandard, or anything like that, obviously. So I think down the line, I think it might be interesting to try Git submodules, but I've had mixed success with Git submodules. Sometimes they work for projects, sometimes they don't. I think it'd be nice to do it with Git submodules because it's a bit easier to track things that way. But we'll have to see how we get on at that point. It could very well be that we might end up choosing to go for the approach that GCCO did, where you actually pull in a copy of those libraries that you care about or whatever you want. But we'll figure that out down the line. And the other question we have here is, do you plan to use and pass the Rust test suite? Yes, that's one of the things we really were passionate about. We want to make sure we get compatibility with the Rust test suite. That's really important. One of the things that in some ways I find difficult, it's maybe a bit more easy to talk about down the line, but the Rust test suite does sort of mix a lot of what it's testing in each test file. So sometimes I quite like writing test files that are explicitly testing a certain thing, but that obviously means down the line you also need to write tests that are combining these things together. But a lot of the Rust test suite does combine here. I'm using a lot of these attributes, and I'm using all of this, and I'm using all of that. Whereas at the moment, we don't have lib standard and so on, so I can't use things like transmute in my test cases yet. So we're building up our own test suite at the same time as this. That's maybe something I'll talk about at the end, about the rationale behind that. So I'll probably talk a bit more about testing towards the end. So some of the benefits to talk about, similar to Antoni's talk earlier, which is fantastic. It provides like an independent implementation of Rust that's separate to the Rust toolchain, so that it actually breaks the dependence on Rust code here. The other part here is that we do get this tight integration with GCC. So we get a lot of the same benefits as being in tree. We don't necessarily have to, patch GCC. We can just, talk directly to GCC as we see fit. That might help, with Rust C bootstrapping in the future. That'd be an interesting thing. We can natively just support GCC plugins. We're already running our test suite that, runs LTO and so on, because it's just a normal front end. It just acts like a normal front end, which you'll see later. So there's also like a useful link in here in the notes that links to a paper about you don't want to do LTO with mixed languages in terms of like, oh, I built this thing with Clang and I built this thing with GCC. You kind of lose LTO and CFI there. So that's another motivation and benefit. You want to be able to provide the full GCC code generation experience, and so you do avoid those problems. We also want to drive adoption of Rust. So if you're some company that only has a GNU toolchain. If you then because we're tightly integrated with the GC, hopefully then you just get the Rust front end for free, which might provide more backporting opportunities and so on for Rust in general. One of the other things, it's sort of something as a future goal down the line. This is not something we're looking at right now, but we bootstrapped the front end code from the GCC code, GCC Go code, sorry, which means there is actually an abstraction over GCC in there, which we've been playing around with to get right for Rust. Currently, for when we started, it was very Go centric. Like for example, temporary variables were prefixed with Go temp. It's all sorts of silly things like that, and things were marked with decal uninlineable by default, and all sorts of stuff like that. And we want to fix this and maybe change it / potentially get rid of it. We're not sure, but if we do keep this abstraction in there, one of my goals always was from the start, it'd be really nice to have like an independent implementation that you could then pull out and use for like something completely crazy, like I don't know, .NET or JVM or something weird, so that it's just that you just need to provide a backend implementation. Though in that we are reusing things like GCC's constant folder, so there's hooks in there that we want to make sure the target you're trying to put this compiler into does give you a constant folder, for example. But yeah, and then obviously we get the other systems that GCC supports, which is obviously of interest to the Rust for Linux project. So how, as I mentioned, this project started back in like 2014. The Rust was still like 0.7, 0.8 around that time. I just really enjoyed compilers, and I started finding Rust pretty interesting. And I remember the first thing I wrote in Rust was like a Lisp interpreter that was sort of half finished. And I remember just thinking, match statements are just class. I just thought that was the coolest thing ever. You had to look at things like Scala and all those sorts of other JVM languages to get interesting functional things like that. But having that in an actual native language just was that you just knew that having those features from the get-go in a native language was going to definitely be popular. The only thing with that was back in Rust 0.7, 0.8, whenever you wanted to like allocate something on the if you want to put something on the heap or if you wanted to put it on the stack, you had to use these little modifiers like tilde and ampersand, and you had to if you wanted things to be boxed and so on, you had to use the @ symbol, and there was talk about adding a garbage collector. And I remember I had like a whole bunch of this sort of stuff sort of working in the compiler at one point. And then I realized I hadn't actually checked what Rust was like in the course of 2 or 3 weeks. And then all of a sudden it was all gone. And that's when the whole boxing thing started coming in. Yeah, so it was pretty hard to keep up with the pace of change because it did change quite a lot back at the start. But since definitely, I would say 2018 for me, that edition really has started to stabilize the core of the language. And so I think since 2018, it did start to make a lot more sense. I was able to write some more smaller projects in that time, just in my spare time, which I really enjoyed. And so I remember I really did enjoy working compilers, and I thought, well, let's start this again. Let's see what it's like. And so we started the community effort back in 2019, joined forces with another guy. And so we merged our parser and AST implementation and started moving forward since then. But since the recent, interest in the Rust for Linux ecosystem, I've been contacted, all by Brad Spengler from Open Source Security and Ebacosm to support this project. And thanks to David Ellison from the GCC Steering Committee for linking all this up for us. And currently I'm actually working on this full time at the moment. So thank you to everyone there for making that possible for me. So currently I'm planning to try and get to a minimal viable product, compiler by, hopefully the end of next Christmas sort of thing. That's sort of where my rough estimate is trying to get us to something that's compiling something, which basically means probably something like Rust without a borrow checker, kind of like mrustc, but I'll talk a little bit about the borrow checker towards the end about that. And so far, done a bunch of different stuff. I've kind of tried to break down the project into like sort of high level features. You know, it's pretty difficult to do that with Rust, I have to say. You know, so core data structures, that was all about like, oh, can you actually do you have primitive types? Can you compile like an integer and do some basic math on them? Control flow 1 was all about like, oh, can you actually, you know, call a function and take the result of it and all that sort of stuff. And then generics, you know, actually having generic structs and generic functions and generic impl blocks and all the different associated things there, because you can actually do traits until you have generics done first. So I've done sort of core trait resolution, sort of been working. And now we're on to control flow 2, which sort of is going to tidy up an awful lot in the compiler at the minute. So control flow 2 is all about, oh, we want to get closures sort of working. We want to start looking at, you know, pattern matching a little bit. We want to fix up some of the bits and pieces of where constraints and bits and pieces around that, which will bring us towards the end of the year. But then obviously macros and config expansions, they haven't been started yet. Imports and visibility hasn't been started yet. There's all sorts of unstable features we haven't looked at yet, mostly around const generics, and there's generic associated types are coming up. And I think I remember reading somewhere that, I could be wrong with this, but like the box keyword might be getting removed or something like that. I might be wrong there. Intrinsics and built-ins and so on. So they're not really started, but that's maybe not fully true. The community has actually started an awful lot of these things. So some of this is all sort of started. And so that's kind of nice to see that that maybe there's the community might be able to help me out here a lot. So yeah, let me just give you like a quick run through of what this actually looks like. What will you actually get at the end of this? So I'm not sure if you can see my screen yet. I'm not sure what's the best way to figure this out if you can see my screen. Is it viewable?
Yep, we can view
okay.
it. All good.
Awesome. So I've just got a couple examples here. I just want to give you an idea of what this looks like. So let's just do the classic hello world. So as I mentioned, we don't have macro expansion, and we don't compile a standard library yet. So this is literally, oh, here's an unsafe block to call printf. So what does it actually look like? You know, Rust C, you do Rust C -G, whatever. But GC Rust, you know, you compile it as if it's like a normal GCC program. So I've got the compiler, -G for debug symbols. I'll turn off debug because it's kind of, a lot of these examples are kind of toy examples I'm going to show you. But a lot of the optimizations are actually working now, which is nice. If I then compile hello, give it an output of hello. And so then I can run hello. So we get hello world 1, 2, 3. So that was satisfying. There's a slight caveat in the GCC version here, is that actually the null terminator string is not really being used at the minute, because if you don't specify that, it actually works, because I'm using like a GCC build string at the minute, which is automatically already adding the null terminator. We know we have to fix that, but it's just not really a huge priority right now. But I'm trying to just use it for now, just to show that it is being respected, because there was a bug in our Lexer that actually, if you use an null terminator string, it was just being stripped out for a while. But anyway, there's hello world working. That's kind of just a nice, simple thing to show. One of the things, it took a long time to actually get to hello world, because we only were able to get to hello world because you need to be able to compile an extern block to say, oh, there is an extern function with this ABI, and it has this these types, like it's got a pointer and it's a radic function. So that means you need to be able to call a function, you need to be able to handle extern blocks, but the more complicated piece is actually this unsafe part. So we do have support for unsafe blocks, but the bit here where Rust, whenever you assign a value of a string, it's str, but actually to pass it over to a some C code, you need to be able to do some casting here. So this sort of relies on having coercion sites at the assignment operator. It also then relies on casting with the as operator here. So there's sort of really subtle things going on here to actually be able to let you compile this in a sensible way without having to rewrite your type system again. So that's been the reoccurring theme with actually writing a front end, is that so many of the features are interconnected, and so it's very, very important to find the right order in which you actually build up your features. That's it's been actually really interesting, and as I'll show you after this demo, some of the things I'm doing around that. So the other interesting example might be something like qualified types is something I've been working with recently over traits. So I know there's a lot of unsafe here, but this is an important test case. It's actually from the Rustnomicon that I've adapted, that, you know, if you're using qualified paths, it's then bringing you to the correct, you know, trait function and so on here. So we can compile all of that as we'd expect. It's the same thing again. Run it with optimizations if we want. File. So, that's the correct result. Just have to take my word for that one. But but the interesting bit in this example is that the point of qualified paths was that, oh, I've given an input block with a function f, but I've also got two traits with a function f. And so you are actually able to differentiate between these using the qualified syntax, because if you just use a normal path, it will then default to the implementation, which overrides, you know. But yeah, so that's some of the interesting things we've done around traits. Another thing we've been is really important to this project is error handling. So this is just a really basic example here, but a bad type error. So for example, here I've got a as a boolean here, but actually we're going to pass this boolean to this function called test. So you should see an error here basically. So yeah, expected an integer got boolean, and so we can see here with the rich locations, you know, we can see this is the boolean here, and we expected to get an integer because of this. So we are working quite hard to try and get decent error messages, which is really important. And for example, the next error message I'm going to show you is an example of why it's so important. So there's if I look at this this example, if you have a generic structure, but you have two input blocks here, you have one that implements it for isize, one for f32, for example. If you're actually then using a path here, it's impossible for the compiler to differentiate which function test here is the correct one, because what happens here is the compiler is going to use an inference variable to try and figure out which one, but there's not enough information to differentiate with them. So, for example, the error you get here is multiple candidate error. So you have multiple applicable items for the scope. The reason that I do draw why these are important is that I do use error messages to try and figure out if we're tackling the particular features in the language correctly. Because if the compiler can't detect a particular error condition, it probably most likely means there's a bug in our implementation. So to be honest, most of the time when I'm going through the Rust test suite, I'm looking for error test cases. And so there is a lot there to go through. And so it helps make sure that I feel sort of confident that we're on the right track. Obviously, in this example, it's a little bit noisy. So you can see this is the actual error, but then we keep propagating the error. So there's some tidy up there to do, obviously, but that's something that happens over time. A lot of these are just sort of catch-alls whenever when we're going over the intermediate representations, we want to make sure, is this thing actually being called for this particular expression and so on. Something a bit more interesting would be like we've got like basic debug support, so it seems to be working pretty good. So I'll show you what looks like debugging through this code. So I can start it, go next, you can print what object is, and we get low here. It's a nested struct, and it's printing it all out for us. You know, and so we can keep going as, you know, and it'll show you like nice little bits and pieces here of what things look like. I suppose I should say thanks to the community's really helped me figure out how to get debug support right, because in Rust there's conventions about how you generate the debug support correctly. Turns out if you've got like a tuple, like the fields with a tuple are meant to be like prefixed with 2 underscores and things like that to get the proper debug support. So there's sort of little caveats in there to like figure out the right way to get this stuff done, basically. The other thing it's worth showing, if hopefully this doesn't go crazy here, I try to be really open about like how I'm tackling this project. So one of the things I did was make this sort of spreadsheet, and I sort of went through the Rust like book to try and like take out all these like high level features and try and figure out a best way, like where are we in this, and sort of track it this way. It was difficult to set up at the start, but I think it's been worthwhile to try and figure out where we are. But the other thing is, I keep this like reporting repository open on GitHub. So we keep a weekly report and a monthly report. So it keeps track of everything that we're doing. And I like to go into detail about what the contributors are doing. I really do like to big up like what work every person is doing. And I like to show examples and talk about the examples about how they work and so on. So I've got multiple tabs of that open. So a report might look like this. So we've got some sort of deref working. So we finally able to do methods without having to have the exact type. The compiler will inject the reference and so on. There's also, we fixed up some of the debug support. So we give links to like Compiler Explorer. Whenever the Rust for Linux project, give this example for Rust for the different compilers. There was a bug here that we weren't actually getting this optimized correctly, so now we are getting it optimized, so it will detect this. And I like to be able to describe, show where are we with the issues, how many issues have been created, how many test cases have we added, how many bugs have been found, how many bugs have been fixed, what sort of percentage are we going through, any risks, and so on. And so that's kind of a rough overview of how the project looks like at the minute. So we'll stop sharing. Another question I get after that is this compiler pipeline that work. This diagram's a little bit out of date. There's some extra steps in here, obviously, but the overall idea is like, there's a lexer, there's a parser, we get an AST, and we have a macro expansion pass, but it doesn't really do anything. There's hooks in there though that we actually macro expansion and config expansion are 2 separate things, but it's represented as one thing here. So not quite right. We've got name resolution, we've got HIR lowering, we've got type resolution, and then we've got our generic backend, which is a terrible name, but that's us, generating the GCC code, and then we give it to GCC. So we aren't doing MAR because I think MAR looks a lot like GCC's generic in a lot of ways. But yeah, this kind of rough overview of what it sort of looks like. And we'll talk a little bit about the community. So one of our contributors, Mark, he sent us this lovely picture. He's got his custom keyboard project here. He's got a little Ferris, and for all the contributors, I've actually sent out a little mug to say thank you, saying compilers are hard, and they most definitely are hard, but they're pretty satisfying. And it's also holding on to the wee GNU logo. And so the goal here is we want to make working on compilers fun. Obviously, I'd mentioned earlier, we've done status reporting, and I want to shout out to all the contributors every time I do that and be as open and transparent. And one of the things we do have is this monthly community call. It's on the first Friday of the month. It's kind of a good time for me because that's 10 a.m. for me at the moment. But I think we might be looking at either doing a second call or moving the call to maybe if there's people from different time zones looking to join. But most of our contributors are within Europe at the moment, so it's worked out okay now for so far. And so we do that, and anyone's welcome to join this. We give out the details in our status reports, like how to join it. There's just a Jitsi link, and so you don't need to necessarily join up to our Zulip server or join our IRC or our mailing list or anything. You can just click on the Jitsi link. You can turn your camera off and just listen, or some people like to participate and ask us questions and so on. We're also part of Google Summer Code 2021, and we had 2 projects that went pretty well. And our first project was the Cargo GCRS project by Arthur. So he was actually able to then give us I think it's using like the Rust C wrapper interface and with Cargo to actually let us, map what the expected arguments are from what cargo thinks the correct arguments are over to GCC arguments. So the goal here is that we want to be able to provide the correct sort of interface that that people would expect, because people are most likely going to be running this project from a cargo perspective. So it looks like a cargo subcommand, so it'll look like cargo GCRS blah, and so we get all that support. The other project was a student from China, and he was also able to give us a dead code pass. So like, as I mentioned earlier, we do put a lot of effort into what our error handling looks like, but that also means, one of the other great things about the Rust compiler is that it's got really good warnings. One of the most important one of those would be the dead code pass to me. And so he was able to provide us with basically following very similar algorithm to the Rust C one, which was satisfying. So you'll find all the entry points and then go through all of those to find where dead code will be. Also, to even able to find, are there fields being used or not in structs. So the other thing is, like, anyone's welcome to get involved in this project. It is a GCC project. But so I want to sort of give a wee bit of a shout out to some people. There was Joel, who was sort of a parser in AST, and then recently, Mark Wheeler was able to add support for unions. Mark Pulleys was able to add module support. Arthur gives support for module expansions. He's working on the V0 mangling and so on. There's also Thomas, who keeps us up to date with GCC and built our test suite with Mark. And I really thank all those contributors so much. There's been a lot more contributors than that. I've given out over 20 mugs at this point, and I just think it's important to say that with this project, there's a lot of scope for people to make their mark on the compiler, like to actually own something or get experience if they wish. And I want to make it as fun and as enjoyable as possible. So we keep a list of good first PRs and so on, and so we do offer some sort of mentorship there, and we try to give good guides. So we sort of list in tasks and so on that task would break down into, and we get a lot of really good support from Philip Krones and Bjorn here. Like, they help us figure out some of the nuances with Rust in general. Sometimes it's hard to figure out all of these bits and pieces with Rust, and it really, not all contributions have to be code, especially when you're trying to figure it, oh, Rust is actually doing a move here, or how does this qualify? Like, recently, trying to figure out qualified paths was kind of difficult. So it is really nice that people do join and offer us help that way. Also, we are in Compiler Explorer as is shown, and so feel free to give us test cases of bug reports. There's going to be plenty of bug reports to raise. Obviously, we're in an early phase, but I think finding the bugs early is useful. And so future work. So one of the things we haven't on the roadmap at all is a borrow checker. But I personally think the best scenario would be for us to start looking and working with the Polonius project. Because that would give us maximum compatibility with the borrow checker. And it is such a core piece of the Rust ecosystem, is getting that right. So I think definitely in the short to medium term, we have to be looking at working with the Polonius project. I don't know if there's much appetite to rewrite a borrow checker in C++. But yeah, it's definitely off in the distance for me right now to even think about. The borrow checker doesn't really drive anything to do with code generation so far as I've found. The drop trait, it's kind of, you can figure that out without requiring a borrow checker. One of the things we haven't done is incremental compilation as well. Like the Rust toolchain, it works by everything in the crate is a single compilation unit. So whenever you have a mod keyword, it has to load that file. So that means, your actual compilation unit is actually encompassed of many files. As I mentioned at the start of the talk, we were interested in, potentially with this abstraction, trying it out with other compiler infrastructures. That's definitely way down the line. There's no point even trying that until we get it working with GCC first. But it's something I found interesting at the start when working on this project. And the other thing is we do really think it's really important to drive compatibility. So we are seeking to potentially, create like a testing project there. We do want to try and reuse the Rust-C test suite. One of the potential issues there is that, the GCC code is a GPL project, but the Rust test suite is like, MIT or something. I can't then just copy the test suite into GCC code and pretend it's ours, so it'd be nice to have like a separate project that will actually have some sort of driver to then invoke those test cases dependent on the compiler you want, because at the minute our test suite is using Deja GNU, whereas the Rust-C test suite is a different thing. I don't know what it uses under the hood, but it would be nice if we could actually just run the test suite as we would expect down the line, because at the minute we're sort of cherry picking test cases to actually test our code against. Then the other thing would be, I'll be interested in that down the line to backport the front end, because we have built this front end based off some GCC code, like which was built like as a GC5 or something like that. There's a lot of scope to backport this. So if we keep the abstraction in a certain way, in theory, it shouldn't be that painful. But that's one of those things. It's like, oh, it's a one-line change, but really it turns into months of work. But yeah. There's some questions, I think, coming in. To what extent could you reuse Rust libraries within the front end? For instance, since you've shown the traits are one of the largest blocking gaps, could you pull in Chalk library, which implements the Rust trait system, increasing parts of the compiler being modularized to reuse Rust? So that's definitely been posed quite a few times to us at the start. One of the issues I have with that is that I personally think it's a better solution for the long term if we can break the dependence on the Rust toolchain. I think having a separate implementation really helps with that, and potentially maybe down the line after the chain has been broken, then you could start doing something like that. I'm just not sure what. The only benefit it brings to me is, it sort of might reduce some work, but at the same time, it's not really helping with bootstrapping or getting it onto different platforms, because you're then still limited to the platforms Rust-C supports. I kind of think it's better to break the dependence. If you would say how easy it is to add support for architectures. Yeah, so one of the things, because we are reusing a lot of GCC stuff here, we are already working on many different target platforms. And so we do actually, thanks to Mark's build farm, we are actually testing that regularly, which is nice to see. And there's been a Debian developer, John Paul Adrian Glaubitz. He's been really interested in MIPS and so on. So that's been pretty cool. The actual act of testing the compiler in these different platforms has actually rattled out some interesting bugs as well. So, for instance, like float 64s just didn't really seem to work at all until we got some patches through there. But yeah, so it's been pretty useful to test it on these different platforms. A lot of what the language in Rust is, a lot of what looks like the language in Rust is part of the standard library, somewhat like Java. How good Rust can be at a GCC front end without tight integration, without a standard library? How does it work with tight cargo integration? I'm not quite sure I understand what the question is here. Oh, I'm sorry, I'm trying to figure out what the question is of that one. For an end user, Rust-C is not there. Do you mean like, cargo support? Yes.
Yeah, maybe some of those who are typing questions can just basically ask them verbally and turn the camera on as well if they're having troubles.
End user, we'll see, is not there. Users use cargo and stuff, so it's a bit odd without all the stuff. So I think trying to answer that question, do you mean like we don't have the standard library or something? Well, the goal here is that we will be reusing the standard library. It will be a GCC Rust built standard library, libcore, liballoc, and so on. That would be the goal here. And we want to minimize the incompatibilities that could arise out of that. So I don't really think, and obviously we have thanks to Arthur's Google Summer Code, we have the cargo support now at the minute. We've been trying to address these questions early to try and gain as much, trying to get ahead of those potential problems. I'm not sure if that answers your question or not, though. Special thanks to Brad Spengler and Jerry Bennett and David Ellison, because they've been really helping me navigate this project in general. Brad and Jeremy are sponsoring my work here, and I get a lot of mentorship from David to figure out how to actually go about this project. Being a maintainer like this is new to me, and I really do enjoy working on this project, and I'm hoping I'm making it enjoyable for the community so far. So yeah, questions. Here's all the relevant links, by the way, for if you want to figure out where everything is. And we have a mailing list as well, and we're on IRC and Zulip and everything. Oh, hi, Miguel.
Hey, Philip. Thank you for the talk.
Thank you.
Well, I was going to make you the same questions I made to Anthony in the previous talk, which is just in case you have some input there. So basically, as you know, in the kernel, we use binding to generate the bindings to parse the C code and generate the equivalent to the C headers for Rust. Right?
Yeah.
But that uses liftran, which poses a problem because, of course, with GCC, it could be the case, for example, in particular, if you are using a plugin in GCC that randomizes, for example, the layout of a struct, for example, then the ABI wouldn't be compatible. So do you think, or are you planning to perhaps work on that, perhaps as a parallel project or somebody else to add support for binding, for running, support to binding as a, so using GCC as a backend for binding. I know that as David was telling us 1 hour ago, it's not possible easily with GCC to get into the middle of the,
I have some experience with that actually, because I did Google Summer Code in 2010 and 2011 and so on. One of the years I did it with the Python Foundation. So I actually worked on Cython at one point. And so the project there was actually trying to write a Python plugin to then generate all what Cython calls PXD declarations, a similar idea. And one of the things there is it worked actually pretty good. One of the problems was actually getting the information from preprocessor macros, so you couldn't access those because they're all sort of encapsulated then into the IR. But the overall problem that really stalled the project from being useful was that if you use this, you could power this plugin and run it, but at different subsequent GC versions, the behavior was completely different. And so that made it kind of difficult. But as far as I know, a lot of that is stabilized. Whenever I was doing that project, GC plugins were kind of just new, and the GC was changing quite a lot. So that was like GC 4 or 5 or something like that I was working in then. We're quite far away from that now. I think it would be definitely worth investigating like a plugin approach like that to get information. I think well, it's an interesting thing you say there, because at the minute, one of the things our front end doesn't support. This doesn't sound related, but it is it's related. Or doesn't support parsing like UTF-8 stuff, which Rust does. And so at the moment in GC, there's code in the C front end, there's code in the Go front end to do this, but they're all separate implementations. And it would be nice to start trying to unify some of this work to actually be able to call each other's code instead of having to re-implement everything. like another similar problem that I had was right logging in this compiler. I've currently been using a lot of Rust debug, just printf stuff. But Dave Malcolm has this awesome logger there, and I've got a patch to then extract this out. So I think some of the problem there is that we could maybe work better at making reusable parts of GCC. Which is what I'd be interested in doing. So, and to answer your question, I think it'd be worth trying again, given where we are now. But yeah, I think one of the things that's interesting here is that because I'm tightly integrated with the front end, tightly integrated with GCC, we're actually able to then call a whole bunch of stuff. So like, as far as I remember, there's a bunch of stuff for like security and vtables and all sorts of crazy stuff like this that I could potentially reuse from the C++ front end. And so that's what I'd be interested in seeing is, can we extract things out to make this easier for more front ends in general? I think I went a roundabout way to answer your question there, but
if I understand. No, I mentioned this, and I also asked Anthony because basically for any project, not just the kernel, but any project that is written in C and they want to, when they want to adopt Rust, they will run into this, like I want to automatically generate the bindings because I don't want to write them manually, of course, and then there is this possibility of issues. So I see like as a piece of a toolchain, so to speak.
Yeah.
I see it as a piece of GCC. I could even see it as a piece of GCC, let's say.
Yeah.
So it will be, yeah. But of course, I mean, many user space projects, it works even with libplan, it will be compatible. So it will not be any problem. So it's only special projects, I guess. But yeah,
yeah. I think that's one of the benefits of Rust, though. It has really good support for stuff like that. Like any other project like Cython, for example, you have to go and manually create all these things, and it makes it so ugly if something there changes. And like Swig will get you so far, but Swig also has its own issues. But I also do quite like Swig at the same time.
Well, thanks a lot for the talk and your work as well. I hope in 1 year, 2 years, 3 years maybe, we will be able to compile the kernel with GCC with the Rust support, of course.
We actually, I forgot to mention, there's actually a project, is it called Blake 8 or something like that on GitHub? It's like a nice minimal Rust program. So we're hoping to be able to compile that by Christmas. It basically doesn't really use any real standard library stuff. There's a couple in there, but we can extract it out, I think. So it'll be interesting to see how many bugs we find. Because whenever you posted that Rust for Linux compiler explorer example, there was like 5 or 6 actual bugs in there in our compiler. There was what people only noticed was that it was missing an optimization, but what I saw, there was like 6 bugs. They're all fixed now. But that's what I think. I was initially pretty nervous about being on Compiler Explorer, but it's been really worthwhile because it's better tackling these problems.
Yeah, sorry if it was too early. But I think it was very nice. It's very nice to have it as soon as possible and so
No, I think it was fun.
Putting the thing up on Compiler Explorer. I know we will probably flood you, yeah, in English. Like,
yeah, that's good. I mean, then people are using it in anger and finding the real bugs instead of us finding it right down at the last minute.
Yeah. Thank you.
No problem. Clarification, Rust libraries. I understand that you want to be able to bootstrap via GCC. I'm asking, once you have some minimal level of Rust support, could you then introduce Rust code into the front end, which would then allow you to reuse Rust code? Yeah, that's definitely something I've considered. I think we're still quite far away from doing something like that, but it's definitely, I would prefer that approach than doing it from the get-go. Yes, so I just want to give a shout out. There's Open Source Security Inc. They've been sponsoring a project as well as Embecosm, so you can find their URLs on Google. And also GCC Steering Committee as well. If I go back a slide, you can get their links. If other companies are interested, I'm not sure if I can talk about all that yet. I think this has been we want to try and drive to create a project that other companies are interested in joining. I think, yeah, so we want to make it sure it's something that solves something for the community, and we want to make sure it's welcome for other people to join in and work with us as well. Well, there's something raised hands. How do I have to click on that, or?
Yeah, yep. If you click on that, that should do it. I can't see it when you're presenter, sorry.
I clicked on something. I don't know if that was the right thing to do.
It was me.
Oh, yes.
Thank
So,
you, Jeremy.
all it was to say that, you know, Brad and I are not exclusive about sponsoring this project. It's a great project, but there are more people coming down the track who'd welcome an opportunity to be supported on that, and we'd encourage other sponsors coming forward to assist with that. So you can reach out to any of the 3 names on there if you think you might like to sponsor in any way.
And thanks for you guys sponsoring my work. It's made a really great year for me. You know, I do really like Rust, and I really like GCC. I've always wanted to work on it full time. In my previous experience, I've done mostly LLVM work, but yeah, I've always have a soft spot for working on GCC. I think I've done all the questions. Unless I've missed any, or
Yeah, I think you've done them all as well. So on that note, I guess probably, you know, keep an eye on the chat when you're actually able to have access to it, I guess. Yeah. And thank you very much for a really good talk. Much appreciated.
Thank you.
Okay.
Well, have a good day, everyone.